Waiting for the link to come through. Okay. Okay. It says that you're online. Someone's watching at least. Okay, so let's start out with making a. There's two ways of making flamethrowers. The first way is to make a volume and use like a just using volumes, honestly. And then the second way is using particles. The particles might be better for you in the shot you're doing, but I'll show both ways. And I've got some old tests up here as well that I've been working on, just so that I know what I'm doing. Okay, cool. So to start out, I'm just going to lay down quick geometry. Let's just say type 1. My Y key is not working anymore. Okay. And I'm just going to quickly save this, set project, new project. Let's throw it into my projects here. Flamethrower. I don't need desktop, video, audio, comp, scripts. I don't need any of these really. I need books, renders, maybe textures. Yeah, I'll keep that. Alembic, sim. We won't need the HDA, but we'll need all those. Okay, and then I'm just going to save. So I should be able to do a good job. I can just say flamethrower. Like so. Okay. Just some quick setup. So I'm going to start out by just making a tube, which is going to represent where the flame is going to come from. I'm going to make it a polygon mesh. I'm going to do end caps. I'm just going to set it to along the x-axis, and I'm going to make the height a bit longer, by about 5. I don't really care about the columns, but I'm just going to increase it so it's nice and smooth. And then I'm going to put that in a VDB, and yes, I know the size is massive currently, but we can scale it down later on. But from my tests, it proved to be better to do it like this, to just have it at the scale we have now, and just go with that. But we can look into it later. So I'm just going to say VOG VDB. I'm going to say surface attributes. I'm going to say bring the position attribute over, and we'll just call that velocity, or vel, short. I'm going to change it to a vector type displacement. This just means it's not normalized. By the way, if I'm going too fast, or if you don't understand something, please just ask. Otherwise, then I don't want you to get lost. So what I'm going to do then, so I've got a velocity field, I've got a density field now, as we can see. And let's just visualize the velocity field. Actually, let's just go with this for now. Let's lay down a dot network. I'm going to disconnect that. I'm going to say sim. Color, nice red color. And down here, I'm going to put a null. Say out. See. I don't really know what to call it, honestly. Outsource. Okay. And I'd like to color those green. Diving inside, we're going to use the sparse as help with memory. I can show both ways, but the differences there are going to be a little minor in how the flames and how it's all igniting and stuff. Then I'm going to put down a volume source, link that one up. I'm going to add a density here into here. So my source volume is density, the target field is density. I'm going to enable the enlarge fields so that the sparse can actually work. I'm going to keep it at 0.1, just hit go, and now we have our density. So I'm also going to go to my smoke object, turn off density, go to multi-field, plug in density into here, and then I'm going to put down, I can either put down temperature or flame. I'm going to put down flame. I'm going to put it to 1. So the way that the sim now works is if you have, well, the sparse side, I should say, now works is that if you have a field called flame and a field called temperature, both flame is mainly the one that you want. That's going to be the ignition. We used to have fuel, and we used to have so we had fuel, we had and temperature, and the temperature would burn the fuel. We can still technically use that, but it's a little harder to implement. I'm just jumping through all my old projects that I just did, just to make sure what I'm doing. Yep. Okay. So what I can do here is I'm going to split out all these volumes. So I'm going to say split. That's not split. And if you're wondering what the split does, it is literally, if we dive inside, it's just 2 blast nodes, one with non-selected and one without. That's all it is. So I just plug this in. I want to split out the density, so the density is coming in on the left-hand side, and the velocity is going to come in on the right-hand side. So I'm also going to put that in merge, because I actually want to merge that back together, like so. The reason I'm doing this is because then I can just duplicate the density field here and rename it. So I'm going to say name, plug it in, and I'm going to say grab the density name. I'm going to call this flame, and now we're going to have density, val, and flame, and they're all going to be the exact same. Well, the density and flame are going to be the same, but velocity is going to be different, and we'll visualize that in a second. I just want to get this flame working. So honestly, I could have just said density to flame, and it would have given us the same result. And now you can see we're getting something in here. See how it whitened up quite quickly. To actually make it explode a bit more, we have to add temperature into here, which will then give us this. We then basically just move around with these ways of doing it. So I'm going to say 0.3, 0.9. Expansion I'll talk about in a second. We also have a smoke one. I'm going to set this to 0.1 and 0.9 here, and I'm going to say remap smoke. So what this does is it takes the flame range and it says from 0 to 1. So basically it first of all normalizes it. So it takes it, if the flame goes from 0 to 100, it sets it back down to 0 to 1. And then we're going to say if it's between these values, then emit smoke. So if I quickly simulate that out now, and let's turn down the emission of the flame for now. You can see we're getting some smoke. Let's try and get a bit more. So I'm going to go a bit more like that. Let's, instead of doing max, let's say add. And honestly, this is a little hard to adjust. So we'll get to this later. Let's just turn off this remap smoke. Turn it down. I'm not sure if that was the remap or the fact that I set this flame range here back. So it was this remap part here. So that's the smoke coming up. Let's also add a gravity, because we always need gravity. Gravity will pull the smoke down and give us this pluming effect. We also want to go to advanced, go to external forces, and we want to say not gravity. I can't remember if it's with a capital G though, so I will just quickly check. It is not telling me. Brilliant. So it's either gravity or capital gravity. Didn't really see a change there. Didn't really see a change there. Okay. Yeah, so it'll be gravity. It'll be capital gravity there, because if we go into here, we've got the data name, which is under forces, gravity. Okay. Okay, let's go back to... Oh, you didn't hear me. What part didn't you hear me? What part didn't you hear? I'll try and put the mic a bit closer, if that might help. I am talking a bit silently. Okay, cool. Cool. So now that we've got this working, we can see how it's doing that. I'm going to actually just go back and let's start messing with this. So actually one other thing that I want to talk about is the expansion here. And the expansion is taken from a what we call divergence, and it can be quite destructive if we let it really hurt ourselves. So we kind of want to make sure that it doesn't expand too much, and instead we just want to make sure that it just expands in the areas that we want it to. And this is just becoming an explosion, honestly. It's not what we want. So let's turn off the expansion for now. Let's keep this. Let's actually just revert these to the defaults from 0 to 1. Let's keep the smoke. What I want to do here is I want to now talk about the velocity and why the velocity is very important. So let's just figure out how to visualize this. If I say a volume trail, the first input is going to be points, second input is going to be the volume. So I'm going to plug that in here. I'm going to lay down a scatter node, plug that into there. I'm going to say scatter along the density, please. We can see it there. I'm also going to change my viewport to dark so we can see it a little easier. And then I'm going to say volume trail, and I'm going to say velocity volumes is val. And you can see what it's doing is it's currently just pointing outwards. And the reason for that is because we set the velocity to be the at p, right here. And this is what that looks like in the velocity form. I also want to say fill interior, so that the interior itself is also getting velocity and volumes. So if we go back into a sim, that can actually change the how it looks quite a lot. Okay. So now what I want to do is I want to mess around with the velocity. I tend to do this in either a VOP or a VEX. For starters, I'm just going to use VOP because it's a lot easier. Plug this in. I'm going to say custom val, And what I'm going to do is, first of all, I'm going to say bind, export, and I'm just going to export the velocity. I'm going to set that to a vector. It can be a free floats vector or a vector. They're both the same. So the difference being is that Houdini native volumes, which is not a VDB, so these are VDBs here, but the Houdini native volumes, which comes out of here, can't read a vector field, which velocity is. So if you see, we've got a vector free field. So what they do is they split it up into 3 separate float fields. So we don't really want to be doing that, but they've left it in the free floats and the vector. They're basically the same. So I'm going to lay down a parameter node, and the parameter node is going to make a parameter up here. I'm going to call it direction, and I'm going to set it to a vector. Plug that in, and this is going to disappear because I need to set a direction. I'm going to set it to 1, so it's just going to go across 1. And that could be all I can do, but I also want to add some variance to that. So all I'm going to do is I'm going to say add. I'm going to use a AA noise, which is going to give me a purlin noise. So I'm going to plug that in here. I'm going to plug that into here. We're going to see a little bit of a change. And then I'm going to put these 3 up so that they're promoted up here. I'm going to turn this up a little bit. So now that's the velocity we've got. So now let's just see how that looks inside of here. The way we can do that is, well, first of all, I don't think we need flame. I'm going to keep the flame for now. Set it to 0. I'm going to set vel to vel. I'm going to make it a vector field. And there's a few options you have. You can use a dot mask or a stop mask. The dot mask can provide some pretty interesting results, honestly. But it depends on how well you are using it and what solver you're using it with. I don't think the sparse solver works well with it. So now we're getting that. Okay, I'm going to turn off the gravity for now. So we can see it's pushing out the density here. I'm also going to go to my shape and I'm going to turn off the dissipation. So there we can see that's working. I'm going to set this up higher. And I'm also going to turn on the flame. It's about 2. So that's kind of looking nice. But we can do a little bit better. So what I want to do is I'm going to add a new one here, and I'm just going to call this, I'm going to put density into temperature, and I'm going to make that a lot bigger. And the temperature is just going to push it right up. So let's actually scale that down. Let's scale this up about 8. And let's try and add a dot mask of temperature here. And let's turn this off from flame to temperature. So we're getting that. Honestly, the buoyancy is a little too harsh. So what I would do here is I'd turn the buoyancy right down. So I'm going to go into simulation. And you've got a reference and a cooling rate. Cooling rate is how fast it's going to cool off. So if I put that really, really high, then the temperature should dissipate quite quickly. As you can see, it's turning to smoke quite a lot quicker. You've got a temperature diffusion, which is how far the temperature will spread, which also helps with the cooling. So I'm going to turn that to about 0.1. Cooling rate to about 0.3, and the buoyancy scale I'm going to put down to 0.1 because I just want to shoot out I just want to really shoot out to the side a lot more, and just have like a small amount of it rising. Even then, that's a bit too much. Okay, so this is very basic. We can make it a lot more better. Well, that was great English on my part. By adding in some disturbance, shredding, and so on. So let's try that now. So we've got advection, we've got forces. I can't remember which one goes in where. Let's try plugging into the forces for now. Let's put it into the advection. I've always put it into the advection in the old way. So I'm going to start out with turbulence. I'm going to plug this in. And I'm going to set the scale up quite high so I can see it's doing its magic. And we can see it's adding turbulence up here. I wanted to add turbulence up here, where it's the strongest. So we've got a control field. And the control field will say where it is. I'm going to say control influence completely. What this is going to do is it's going to say where this is at like 1, then I'm going to add a full scale to that. Where it's less, I'm going to add less to it. But I don't really want it to be added to the density. I want it to add it to the velocity field. But we can't really do that. So I'll show you why. Let's open this up very quickly. And we want to go into this field up here. So this field up here, we've got a force scale down here, and we've got a use control field. This force scale is what this control field is. Hope. Pretty sure that is it. And how we can find that out is we go into our data bindings here. And if we look at our force scale, we've got density, which has been plugged into here. So let's try something else. And we can see that it's being updated. So I'm going to say this is going to be val inside here. And so this is it's going to be taking val in. So this is val, except this is a float field, and it's going to be ranging it from 0 to 1 in the float. We want to make it to a vector because it's a velocity field, and we want to be using that. So the way we can do that is, first of all, we have to change this from a float to a vector, and then I'm going to say get the length of that, which is going to give us the actual, which the length of a velocity field is the speed. So now that we've got that, we should see where that is greater, we should see more turbulence going on there. So let's try and add the remap field here. And let's take a look at the visualization. Visualize turbulence. And we are seeing some turbulence going on here, which is not really what we want. We want it to be going right there. So let's up the control max quite a bit. Maybe even push this down. Okay, it's not quite breaking it up how I want it, so let's put this swirl size up and this up again. Now turn off the visualize, and I'm just going to set it run again. You can see it's kind of doing something weird. So I'm going to turn off this remap. I'm going to bring this back down to 1. Let's try from control. Let's go control min to control max, and I'm hoping what this is that it's saying when it's between these values, it's going to be adding it to. So I'm going to bring this up a bit more, so that we can see that where the velocity is the strongest, that's where it's actually being added. So let's make this 20 by 50. I think that was a bit too less, so let's go 30, and let's say 50. Okay, so this is giving us the larger scale turbulences. which is kind of what we want. So let's add another one. I'm going to decrease the weight of this to about 2. I'm going to increase this, I'm going to keep this about 0.5, and I'm going to set this to 0.5. And we're just going to be layering on a bunch of these different small scale ones. I'm going to set this to be about 9. Between 9 and 20. There is another technique, but I'm not going to be showing that because that's from the explosion workshop on how to get a really nice turbulence. But let's go and add a disturb field. The control field, let's see, I can't remember which one the control field is. So let's just say temperature for now. And let's just put the block based. That should give us a bit more breakup in this. We can also add the shredding and the turbulence in here as well if we want to. I'm going to set the dissipation down. Control field is going to be temperature. The disturbance, let's keep it to that. Let's keep these the same. So this is making a flamethrower from these methods. If we wanted to adjust how this came out a little bit better, we would go back into our custom velocity and we would change this in here. So I'm going to remove this. I'm going to say kill noise. And you've got 2 noises that really kind of stand out. You've got the kill noise, which is this very curled one. I'm also going to keep it. So this one's going from 0 to 1, so I don't want that. I'm going to put the roughness right up. Attenuation down a little bit. And I'm going to keep this down a little bit as well. And we can really adjust the way the custom velocity works as well. So, for example, we can also set the flame a little bit better. So this is the one that's the flame. If I wanted to say, for example, have the flame coming out from this end only, then I could put down a volume block again. Not really speaking, I'm going to put it up here so I don't need to bother binding it to flame. And it's just going to bind to density automatically. So I'm going to say vector to float. So I'm going to be going along the x value, and I'm going to say if it's greater than 0 on the x, then just put it to 1. So I'm going to say compare. If the x value is greater than, then just set it to 1. Or better yet, I'm going to multiply it by that. So we don't get that horrible banding there. Like so. So that's the flame. That's where the flame is. It's kind of buried by the velocity. But now okay, so the temperature is coming in from density. Let's put that coming in from flame as well. Now you can see that the temperature is coming in from the flame. And we're getting this sort of rolling effect. I'll showcase one that I had last night. If I take a look into it. So this is the one I did last night. Let's turn off hide other objects. And the DOP network is going to be just this one really. So I did the same thing. I had a fill interior density, velocity sort of thing. I then blast out the density, which is just a split. I did the exact same thing, this is a VEX form of what I just did. Then I renamed it to flame, and I merged them together. So now I have density flame, vel, and flame. And if I dive inside here, let's take a look. That's not doing anything. Where's all the work I just... Where's all the work? Where's all my work I did? Oh, dear. Where's all the work I did? Looks like I've lost the work that I did last night, so that's great. But a quick overview of what I'm doing here is I've got the exact same setup basically. I am just adding expansion to that. So let's go back and add some expansion. But I'm not going to add too much. I'm going to set it right down. Expansion, as I said before, is like an explosive force to it all. Also going to turn this back on, and I'm just going to revert to defaults. I'm also going to, let's take a look. Oh, this has already got gravity attached to it. That's interesting. I didn't know that. Let's turn down some of the diffusion. So I'm going to say cooling rate back to 0.5. This to 1, honestly. The advanced, so I'm going to turn off this gravity one here. And that's all I really wanted to do. This is a very basic form of a flamethrower. There's a better method though, which involves using particles, which is probably the method that you can use both of them honestly, depending on how forceful you want yours to be. So I'm going to turn off this DOP mask actually. I'm also going to turn down the smoke. Actually, I'm just going to turn down the smoke completely. Emit smoke, turn off, or just say max. We're not really getting a lot of flame there, so let's just say density and density, and so on, so that it's just bringing it from the density itself. So it has a greater, more oomph to it. And you would break up the temperature to give it a bit more of a breakup, so it's not so uniform as it comes out. So let's just do that quickly. I'm going to say flame to flame. So, and under this volume VOP here, I am going to turn this off, take this out, and I am going to do just look at noise. So let's just make a Voronoi noise. The Voronoi noise, I'm going to subtract the two distances together, switch them around, add the position into there, add that one, and we're going to get something like this. We can then just, so, no, did I just, oh, great. Brilliant. Okay, let's try and go back and see what I didn't save. Didn't save any of that, it would seem. So let's dive back into it. Set that coming into there. I'm going to remove this. I am going to set the cooling rate back to 0.5. I'm going to say this won't scale to 0.3. The flames I'm going to say set to max. And expansion I'm going to turn on. Set to 0.3 maybe. That was all I wanted to do there. Let's go back to here. Go down to volume up. And I'm going to put down a Voronoi noise. And instead of mucking that up again, what I'm going to do is we've got like a 4D effector noise that we can bring out, which will give us position and time. So what I want to do is I can say velocity, I can say vector to vector 4, which will give me a vector and then a fourth vector I can add. So I'm going to add position here, like so. I'm going to do the same thing. I'm going to subtract both those, switch them around by pressing Shift R, and then I'm going to multiply that with this. Quickly visualize it. Nothing's going to be happening yet because I then want to say time. And that's going to offset that a little bit. Cool. That's all I wanted to do. That will give us a lot more breakup. Although we may need to set. No, it is fine. Okay, whatever this is too. So I'm going to set it to a clamped ramp. I'm going to set it to black body, which means I then have I can adjust this. So I'm going to set this down a little bit. I'm also going to get the old smoke object because that one had a better preset for this. I'm just going to say copy parameter and paste values. Okay. So now we've got that. Let's figure out why this is dying so fast. This is probably the dissipation, honestly. So I'm going to turn down its cooling rate. I'm also going to do dissipation is very small, because I don't really want to dissipate that much. I'm still seeing a lot more smoke than temperature. So let's try again. Set a pool, let's say add. It's giving us some really weird results, honestly. So let's send it back to pool. Turn up the amount of temperature it's going to give. I'm also going to increase the expansion. And this might just blow it completely up, honestly. Nope, okay. So let's talk about how I would do this in the old smoke solver, which the setup is almost exactly identical. To the point, I'm just going to duplicate this. And what I'm going to do is I'm going to say smoke solver. I don't even going to bother with the Pyro solver, honestly. I'm going to say smoke object, and then a resize fluid dynamic. Those are the only nodes that I really need. Maybe the gravity, but so we'll look at that later. I'm going to get rid of these. I'm going to plug these all in. The gas turbulence goes into velocity update, and then we go into the sourcing. Just plug it in there. And we can see that it's not quite working just yet. So what I'm going to do is I'm going to go out inside here. I'm going to put down a bounding box, and I'm going to say outbound. This is going to help drive resize. So we can't just say enlarge fields to contain sources. That's just not going to work. That only works with the sparse solver. So what I'm going to do, and we don't need flame, we just need temperature. So what I'm going to do is I'm going to say multi-field again, set density, and this time I'm just going to say temperature. And inside a gas resize node, I'm going to say tracking object is a SOP. I'm just going to paste in the SOP path. I'm going to go into my max bounds and I can say clamp to maximum, turn that off. You see, it's not quite, it is hitting a wall there. So we need to introduce a bit more padding. Or better yet, let's add the reference field as well. Or we can add, I think we add it up here as well. I'm not too sure exactly how that would work. But we mainly just need to adjust the padding on this to make it work. Yeah, so we just need to adjust the padding. So the padding would be about 0.7 because of just how fast it's moving. Okay, there we go. So that's our temperature in there. The temperature is fading off quite quickly. So let's go into here and figure out why. So we've got a temperature diffusion and a cooling rate. Let's turn this right off. No, let's keep the cooling rate to 0.1. And let's set that to go. Now it'll take a lot longer to cool off. Or alternatively, we could add a lot more temperature to it. And then what we can do is I can say, I'm going to put this to density. And we do tend to get a lot better results with that, but not normally, unfortunately. So I'm going to keep that here. That's our flamethrower in a way. We would also add in. So the only thing that this one doesn't come with, which the Pyro one would come with, is the it would come with a lot more options up here. So let's actually grab that one. Let's go Pyro solver. Grab the old Pyro solver here. Let's plug all the right nodes in. Like so. And then we have the shape. I'm going to turn off this combustion for now. I'm going to set this down as well. So I'm going to say 1 to 05. So we should now get, basically, now we've got dissipation. I'm going to turn that off. We should get the exact same result, which we do. So let's talk about the combustion model inside of this whole Pyro solver. This combustion model took in two attributes, which was fuel and temperature. So let's add that. So I'm going to say fuel is coming in from the density. And I'm just going to add it to the fuel. And we can set it to add, or we can set it to maximum. It's not going to change anything yet because we need to actually enable the combustion model. And what should happen now is if normally I tend, instead of maximum, I tend to add, is we should now get like this very bright spark sort of thing. And what we would normally do is we would animate the fuel on and off. So let's do a sine wave, sine of $FF, which is the subframe that we're on, and I'm going to say absolute of that, which means that is because the sine wave goes from 1 to -1. I just want it to go. How do I put it? Let's go paint. So the sine wave goes like that. When we do an absolute, it says if it's going in the negative way, just flip it. So now we should just get like this. That's what the absolute method should do. And it's a little slow for my liking. So the way we can do that is we can times this. So that's times by about 20. I'm going to turn this off so we can see how fast it's going up and down. Yep, that'll work for me. Okay, there we go. And so you're seeing this sort of looking thing here, which is encapsulating the whole thing. So what we can do is we can set the density, the fuel mass, to be masked by the density, which doesn't really work. So we can actually set it to masked by the SOP instead. And the SOP is going to set it to how to put it. It's going to set it properly, so that it's not going to kind of go in and out of everything. So that's the combustion model in there. If we have more gas release, so say 45, 55, then it's going to be a brighter flame, basically. Which may be what you want. Let's put that back down to 15. We've got the temperature output, which if we put that right up to 2, then it's going to put output a lot more temperature at a higher temperature. It's kind of self-explanatory, but the defaults. Fuel inefficiency, so how inefficient it is. So it says control so much of the burned fuel is not actually burnt but kept. That's fine. And we've got this advect fuel. Not always advised, because it can lead to very unusual results. The reason it's not quite working here is because of the fact that I have a SOP mask on here. So if I turn that off, what could happen is we could have a massive explosion, which tends to be the case, honestly. We can see it's getting bigger and bigger too. Best way to view these things as well is to have a light. So I'm going to do a DOP import node to import fields. I'm going to set it to a Pyro, and I'm just going to bring in the so I'm going to say smoke sparse 1. That's going to bring in the sparse solver that we had. And come on. See that coming in here. Doesn't look quite as nice in the viewport, honestly. So let's just figure out how to change that. Quality of lighting, high quality. Volume is high, yes. Scene. HDR rendering, yes. Good. What else? I think it was on the... It's one of these things. Limit 3D. Nope, we've turned the limited off. Got full HDRI. There's one thing here. It's probably this clipping plane, which is clipping volumes. But let's add a light. So I'm going to go up. I'm going to press Control click. I'm just going to add in a directional light of sun. I'm going to frame that up, and I'm just going to add in a fill light, directional light here. I'm going to press O to go back to perspective mode and frame it up. And I'm just going to call this one fill and sun, and quickly just change that around to make it a bit more blue, and this one to be more orange. And then we're going to have some shadows. Okay, diving back inside, I can put down the Pyro bake volume, which I haven't used a great deal of, but it has proved to be pretty nice. I'm going to turn on the scatter, which is going to give us this very flamey looking thing. Be warned, a lot of people have found it's giving us this banding look, which we're still trying to sort out how to fix, honestly. I can also enable the fire underneath, which is going to give us this look, which is something that I prefer, honestly. And it helps if you enable the scatter as well. So I find that looks quite nice. Let's get the other one from Sim 1. This one's the smoke object 1. And we're getting something very, very similar. Just at this one's at a lower res, I believe. There's also the buoyancy isn't even working here, which is a little unusual. That's fine. One thing I'm going to do is I'm just going to put it down to the same resolution as the other one. And then I'll get onto the next method, which is a method that Arvid taught, I believe, which is using particles. Don't make it outside, and we can see that's what it looks like from there. So there's a technique that is taught to give very detailed looks, but that was taught in the first Runaway Explosion course. It's taught in the new one as well, but at a later date than the old one. So the new one, the old one taught this technique in week 3. The new workshop taught this technique in week 6, I believe. But you can find it on YouTube now. Someone has leaked it out onto YouTube. I'm not going to say where, because it's a technique that most people have been using now. So, but basically it uses the gradient of the volume and the dot product and cross product of the volume to create a custom velocity field that pushes in and indents it to make a very nice rolling effect. But okay, so that was type 1. Let's go to type 2. Why does it look different from here? It's unusual. So let's go to type 2, which is a particle-based one. Better hurry, because I do actually have a doctor's appointment tomorrow, but today's the last day I can do a live stream for a few days. So let's get going onto it. So from the method that you were showing, which I will quickly take a look at, you had multiple points and they were all linked together, and the points at one end was moving. So I'm going to quickly replicate that. So let's say we have a what we can do is, you're not going to like it because it's VEX, but we'll try it anyway. So I'm going to make that lay down a grid here quickly, and I'm just going to quickly see your scale. So your scale is about 2, 3. This is about 10. So let's put down 2 by 3 basically. So let's just say this is the person. Let's put it on the X-plane, and I'm going to increase this quite a bit. If I wanted this to be planar, I would copy this. I would say this times by the X coordinate, and this one times by the Y coordinate, which will give us a very squared grid. So I'm going to lay down a mountain. You can use a noise or a mountain. Doesn't really matter, but I don't want it to be so I don't want it to be so rough, honestly. So let's go to you. Interesting. Okay, let's just try the noise. Attribute noise. And we've got a set to P. Okay. Let's just scatter some points on it for now. So this scatter, I'm going to turn off this relax iterations. I'm going to put the points down to about 12. How many did you have? You had about 25, so I'm going to put it down to 25. I'm going to turn off this relax iterations so that we get it relatively close. And then I'm going to put a point block in, and let's just move these around randomly over time, which is, I think, how you did it. So you just did like a turbulent noise. So it's going to add step noise, and then you had like the offset, which would just be animated. So I say add position, move those around. This one was a 3D noise position, and I believe you just used a Polyline noise. It's quite nice. Let's promote this parameter up, and I'm just going to quickly get the same settings you had. So 0.2 and but 2.4. Yeah. And inside of this, you had a dollar frame. Which may, how harsh is that? Yeah, it's pretty harsh, but that's fine. What I want to do is I want to change where it's aiming at over a certain amount of frames. So what I can do, so let's talk about looping. So I'm gonna describe this with an example. So let's go add. I'm gonna add 2 points. 1, 2. And I'm going to set the first one to 1 by 1. Second one 1 by -1. So it's looking at 2 different points right there. So 1 and 2. So let's just look at the numbering. So this is 0 and 1. What I want to do is I want to take in another point. So this point is going to be just 1 point, and it's going to be at 0. I'm going to bring in the second point. What I want to do is I want to get a list of all the points in this one here. And I don't want to really do, don't want to do that every frame, honestly, but let's just keep it for now. So I'm going to say, let's get a list. The way we can do that is I'm going to say int points, and I'm going to put the square brackets in here. I'm going to say is equal to nothing for now, with curly brackets. Don't know why you have to do it this time. I'm going to say full. I'm going to put it in a full loop, and I'm hoping you know what a full loop is. If not, I can explain it. So endpoints 0, 1, sorry, and this. And I'm going to so okay, I'll actually explain. A for loop is going to go is basically going to loop over a certain amount of times. So I'm going to say we're going to make an integer of I say double I because it's a programming syntax. I'm going to set it to equals 0 at the first. And then I'm going to do a check. I'm going to say, is I less than the number of points on the second input? And the number of points is going to be 2. If not, at the very end of it, I'm going to add 1 to my I. And then I'm going to check this again. If I is going to be equal to or greater than the number of points, it's just going to exit out. That's what a for loop does. This point is an array, and honestly, I'm actually going to say I at points like that. And the syntax is a bit different. So instead of putting the square brackets at the start, at the end, we put it between I and the at symbol. So now if we take a look, we've got this little thing in our geometry spreadsheet called points. And I'm going to append into the points array the current point, which is going to be II. So now I've got 0 and 1. But I don't really want that. I want to get the list of vectors in there. And the way I'm going to do this is I'm going to make 2 arrays. So I'm going to say, instead of actually putting it out to an attribute, I'm going to say int points. And the reason I'm doing it like this is so that when I go into my geometry spreadsheet, we don't see the attribute there anymore. I'm going to say vector pos. going to say 2 pos, like that. And then what I'm going to do is I'm going to say vector pos is equal to the point 1 position of current point, and then I'm going to say pos append pos with pos. So I'm now adding to the positional vector into there, and it's going to be the same. So this is going to match up with this. So what I can then do is I can set I'm going to set a vector. I want to set a vector like a normal. Set normal. And the way we can do that is we just say at n equals set 0, 1. So, and that's just going to point out that way. I want this normal to point towards the first point here. And the way we can do that is we can set vector normal there is going to be current position, take away the secondary position, which is going to be 0, 1, 1, 0, 1. So, and then I can just say at n is equal to vector normal. Okay, I've mucked it up. I've got the wrong way around because I'm used to vectors, and vectors are going that way. So we say the first one is the point that we're going towards minus our current position, and now it's going to point to that. What I want to do is I want to set a time period between each. I want to set when it's going to be for each one. So I'm going to set a random value, and I'm actually going to make a float f at time placeholder. I'm just going to say time place. And this is going to tell us, if we dive inside here, this is going to tell us when we want to put it into. So what I'm going to do is I'm going to say if I'm going to say random. So I'm going to say float tr for time random, and so random for the current iteration. That's going to give me a random one for each point for this one. I'm going to fit range this, fit 01 to between 10 and 25 frames, basically. And I want to then add that to my time place thing here. Look like that. You can see that the first one is going to take 16 seconds, the second one's going to take 10 seconds. That is going to be on there. And each one's going to have about a 2-second crossover fade, let's say. So what I want to do here is I want to I'm also going to probably just crush this down. So I'm going to say int. So that way it's just going to either min or max it. It's going to push it down to like a standard floating value without a decimal point, but there is a decimal point there, which is the 0.0. Anyway, but what I want to do is I want to set in a period of time between these 2 points. So what I want to do is I want to say if the II is greater than 0. So what we're going to be saying now is we're going to say if it's not the first one, if it's more than the first one, then I'm going to say append this, but I'm also wanting to plus this. So I'm going to say plus the at time place, and I'm just going to say II minus 1. And then I'm just going to say else. Just do it anyway. Just do this anyway. It is going to, for some reason it's not erroring out, but that's because we've got that in place. So now we can see that this is 16 seconds, this is going to take 26 seconds. Cool. So what I want to do then is I want to set a period of time. So how can I make it smoothly switch between the two? So I can say if, so what I can do, actually I'm going to keep that, and I'm just going to set it to nothing for starters. And I can say if at time place or better yet, we can just do like a for loop for each, and I'm going to say float time between the time place. So now we're going to loop it over each time place, and I'm going to say if the current frame is greater than time, then let's just say at cd equals set. Let's just set to red so we can see. A little hard to see. There we go. So I want to say if it's less than time for now. So we've got the 25, which is this one here. Don't think I figured this one out, did I? I don't think I sorted this one out properly. Probably good with a solver, but I'm not going to use a solver for this. I'm getting a bit complicated. I am very sorry. I just want to have it like a smooth transition between the two. How would I do this? So we've got a few methods inside of Houdini. I'm going to use a solver because it's probably easiest, and this is going to be a very small solver. And what that's going to entail is I'm going to get rid of all this, and I'm actually going to say yes, b at pos, then I at point side. So now, and remember to add the at symbol there. Now we're going to have all these attributes. So we're going to have the position, we're going to have the points, and we're going to have the time, place. So what I'm going to do is I'm going to lay down something called a solver. Inside the solver, I'm going to say, hey, in this previous frame, hey, so attribute wrangle. I'm going to say if, so what I'm going to say, I'm going to get the first value of our array. And the way we can do that, I'm actually going to go back up. I'm going to lock this viewport here so that I'm always going to be dealing with the final result. And so inside of Houdini we have some functions for arrays. And quickly googling that, we have declaring, accessing settings, slicing the arrays, not really what we want. Copying arrays, nope. What I want to do is remove an index. So the way I can do that is I can say, hey, remove index of the array, which will be my at time place. And I'm going to make sure this actually is an F there. And I'm going to say remove the first one. And I might be doing that a bit wrong. There we go. And as you can see, every frame, it's just going to remove it until it has no more left. Okay, not really what we want. But that's basically what the system that we want to use. So we're going to say if the $FF is actually if the frame currently is greater than the F. Okay, so let's get the current index. I'm going to say at time place 0. It's going to error out because it's specified that is actually an array. If it is greater than that, then remove that index. As you can see, it's now removing the index as we want it to. That's kind of going to put it around the wrong way though. So instead of that, what I'm going to do is I'm just going to push it to the other end of the array. And we're going to need this to do this for each of these points here. We're also going to have to do a reset value. So what we're going to do is we're going to say at frame. So I'm going to say I want it to take 10 frames. So I'm going to say if frame is greater than this, so I'm just going to do this. Then I want you to set a timer. So I'm going to say at f at timer quickly, and it's going to be plus equals the at frame value. As we can see, it's going up. So that's not what we want. We want to say, instead of at frame, we can just say +1. So what I'm going to do here, and I'm going to say if the f at timer is greater, actually I'm going to put this one below. If it's greater than, let's say 10, then reset it. Else, just put it there. So if it's greater than 10, then it's just going to be equal to 0. And ideally, what that should do is every time it hits 10, it'll reset. So I'm actually going to say set it greater than 9. So that way, once it actually does hit 10, it'll reset. Okay. I want it to reset every time it's over the current frame here. So what I'm also going to do is I'm going to say f at hold frame is equal to time place at 0, like so. This is the hold frame it's going to go to. And I need to actually set that up here. So that's always going to be set. Okay. And then what I want to do, and I want to say if it's greater than this, and f at hold frame, so then what I want to do is I want to say f at hold frame plus 10. Let's just say plus 10 for now. Actually, instead of this, so I'm going to say if it's greater than this, and if this plus 10, so this is going to be plus this 9, what's here, then remove that. You can see it's kind of not really working, so let's set to 11 instead, because I want them both to disappear at the same time. Nope. Okay, that's fine. Hit 16. Hang on. So it's hitting 16. So once it's hit 16, then it's going up by that again. We might not even need this timer, honestly, because the timer's not even being used now. So let's get rid of it. Okay. So this hold frame, now we need to set this hold frame as well. So what we want to do is I want to remove, even though I want to remove it, I want to actually push it to the end. So what I can do there is I can say remove index. First of all, I'm going to say frame. Actually, I'm going to say for each. I think. So I'm going to set this back to 10. That's what I wanted it to. I'm going to say if for each, if the frame is greater than the time place plus 10, then I want to store the current time place. So float current time. It's going to be this. So I'm storing it. I'm removing the index. And then I want to say pop this current time at the end. This is going to move it to the end. But I need to set a new time for it. Otherwise, it's just going to not really work. So I'm going to say for. So I'm going to say float t time. It's going to be 0. I'm going to do a for each again. So for each. And before I do that, before I actually pop it, obviously, because I still need this in there. So I say for each t time, say float time. I'll just say t, and this is going to be over each time here. This is obviously wearing me out having to plug that in all the time, but that's how code works. I'm just going to add to the time, so I'm going to say t time plus equals t. Once that's done, I can then remove that one, and I'm going to say pop. I'm going to place at the end another one, which is going to be current time plus this new time. So they're both floats. I don't know why it's not liking that. It doesn't like. Float to int. Let's quickly look. So this is current time and this is float time. So I'm just going to cast this so that they both know that they're floats. Like so. Although that doesn't really make sense why this is saying, oh, it's casting from a float to an int. Because this is an F here. Right, it's right there. That's annoying. Okay, so what should happen now is that should be adding onto it. Oh, pop. Oh no, I want to say push. I want to say push. I want to push it onto there. My bad. So now we can see it's changing over time. Mind you, it's not really changing a great deal. So what I want to do then is instead of adding all the ones at the end with this for each, I just want to add the last one. The way we can get the last one is we can say, so I'm going to get rid of this. Let's say current time plus f at time place, and for this one, what I can do is I can put in the same one here. I can say len. I can say length of this minus 1, and this is going to give me the length for the next one. There we go. That's working properly. Well, kind of. Doesn't seem to be, does it? Because it needs to store the original values. So I'm going to make a store original values one. And the way I'm going to do that is I'm going to say f at orig values equals nothing. Actually, I'm just going to set it to this, like so. And that's going to hold the original values. But it's going to change over time, which is rather annoying. So, instead of setting that to the original values there, I'm going to set that one up here. So then we have original values in there. We just need to switch them around every time they do it. So the way we can do that is we can say remove index. Actually, we can say float current time. Say current time orig is going to be the time taken, and it's going to be the orig values from here. So orig values, like so. That's the current time original. And then what we do is we set that and that one there instead. And so we've got the current time. We then want to remove the index of this one at 0, and we want to push this new one on, which is just going to be the current time original here. Okay, so now what should happen? You should have a time, place, and original values, and these should change, but the others should not. It's being pushed onto the wrong one. My bad. So now you can see that they're adding up. So instead of this one, I'm going to say current time is this time, place, and I'm saying current time plus the current time from there. Ooh, hang on. I actually do want to get the current time from this time, place here. And I don't care about the length, honestly. Just trying to make sure the distance remains the same. So the current time must be the original value. There we go. Now it's working. Okay. Now I need to make these ones switch. So, honestly, let's write a small function to do that for us. How we're going to do that is, oh, actually we can't write a function for erase. No, I forgot we can't do that. It's the downside to VEX. I just need to switch these values around. So what I'm going to do is I'm going to say remove point. So I need to say, I probably don't even need the points here. I just want to remove I just want to switch the positions around. So I'm going to say orig pos is going to be basically this, except it's going to be a V, and it's going to be pos, because I am great at naming. It's going to be this. I'm going to remove the index. I'm going to give it a bit of space here so we can see what we're doing. I'm going to remove the index of this. So. And then I'm going to push the value back on. Like that. So now these should just switch. Okay, they're switching. Okay. Now that we've got that, we've got this thing here. What we want to do is we want to say inside here, I'm going to do it after all this sort of kerfuffle. Or I'll do it before, honestly. Before makes a bit more sense in my mind. I'm going to say vector direction. Which I thought I had it up here, but I don't. So I'm going to say vector norm, and I'm just going to set it to 0. Actually, I'm just going to say vector norm 0. Okay. The reason I'm putting it here is because it can change time. And what I wanted to do is the norm dir is going to be where our direction is. And that direction is going to be from here. And I'm also going to say minus at p. So and what I can do is I'm just going to say at n, like that. I'm not going to see any at n just yet. What I want to do is I want to set attribute n here is going to be norm dir. That should now do is give us a direction. But it doesn't seem to be doing anything, does it? It's a little annoying. Because we're getting this over a set frame. So we need to first of all set this up properly. So I'm going to go back up here. And I'm just going to go like that. So now we have a normalized direction. And what should hopefully happen is over time it's switching. Okay. But I want it to be a bit more smoother than that. Thought I had locked that, honestly. I'll lock this again. Okay. I want to switch. So I'm going to say, hey, if it's over this, then I want to lerp. And lerp means to linearly interpolate between two. So I'm going to say, instead of this norm equals norm dir, I'm going to say norm equals lerp between at n and the normalized direction between a certain amount of frames, which is going to be dictated between the current frame. I'm going to fit range it between two values. So I'm going to say fit between this current time here, this current time here again, plus 10 to 0 to 1. What that should do, no, come on. There we go. Is it's now switching between the two. And if we want to, we can add a randomize here. I can say randomize plus channel seed. That'll change over time. And you're going to see that it's kind of shrinking as well. We want it to set this a bit better. So what I'm going to do is say normalize. So I say at n equals normalize the at n. And that's just going to normalize it so that it actually is pointing out properly. Let's try that on here. So I've got all these scattered points here, like so. And I'm just going to set this one here. I'm going to move these out. Where's the center? Where the heck am I going? I'm going to move it that way. And I'm probably going to turn this down a little bit. Honestly, that's a little bit much for me. That is now move between. Actually, I'm going to set this one also to normalized, so that it's not being a bit weird. Okay. Now this is going to give us like this custom. This can be like our custom velocity here. So let's work with that. Let's create a wrangle. I'm just going to set the velocity to. I'm just going to set it to the negative at that end, so that it's facing the other way. Don't know why it's doing that. Why aren't you working now? Oh, wrong. I didn't put down a semicolon, put down the wrong one. So now we should, okay, I actually do want it to be facing that way. So now I'll put down a pop network. I can say, yep, use all points and inherit the velocity. The velocity is going to be very small. And it's not emitting anything at all because I need to turn this off. There we go. Now we can see we've got something like that. Let's just turn this down a little bit. And what we want to do to fix this, well, we can actually add a lot more points. We can duplicate the points. So we can say duplicate point replicate, sorry. Say point replicate, and the point replicate will inherit the velocity. Also the direction that it's facing it, apparently. Which is kind of cool. I'm going to make it a sphere. I'm going to shrink that right down, because if it's closer together, they kind of explode out a little bit more. I'm going to add a bit of noise too. It kind of helps. Oops. Oops. I'm going to turn off the velocity viewport. And now I want to add in a few stepping things. So let's just turn this right down, maybe 0.5. What I'm going to do is I'm going to say positive, I'm going to say forward, or I can say actually say back. And that's going to give us a bit more of a smoother looking line coming out of there. I'm also going to do attributes, and I kind of want to keep like an ID for each one of these, honestly. I don't need that at all, honestly. I want to keep like I give these each an ID. Hoping, yeah, they're not deleting, they're just moving around. That's good. That's what I want. That's what I want to see. So I can just say attribute wrangle, and for each one I can just scale it randomly. So I can say rand v at v times equals the random at point number. That's going to be from 0 to 1. I don't want that. I want it to be fit range from 0 to 1 to a new range of 0.5 to 1.5. That's going to randomly stretch the velocity a bit more. You could use the noise instead, but I found this works better because then we don't have to work with positions. Okay, now we're getting something a bit more weird. If we want this to lerp a little bit better, easier, so let's just say 24 frames. So that's going to take a whole second to lerp between the two. actually, I'm going to put down float frame lep. It's going to be channel float lep frame. And I'm going to set this 24, 25. And instead of plugging in the values there, I can just plug these in here, like so. Okay. So now if I dive back into my pop network, it's still kind of abrupt. It's not really what we want. Maybe if someone out there knows why it's not quite lerping properly, and it's just still just flicking over to the others, because it should be working. Between current frame, time, oh no, time place frame lerp. No, that should be working. It's a little unusual why it's not working, but okay, fair enough. It is just quickly going to the next frame, which is really annoying. Just got a hold frame. Let's take it down with this. Original values, time, place, yep. Okay, so maybe let's not put it down to be that much. Let's put it down to maybe about 8. So we want it to be greater than the set distance between these two. So let's say, instead of these, let's say 25 and 50. That's a little bit slower. Okay, but not too slow. I would like it a bit slower. If anyone wants to point out how they would do that, then that would be greatly appreciated. So I'm going to set the inherited velocity back again, and I'm going to set the spawn time down quite a lot. So I'm going to say spawn time 1.5 with 0.5 difference. Okay, that's a bit too much, maybe. So I'm going to set it to about 1 with 0.25 difference. And so these are done in life expectancy of seconds. Okay. Cool. Let's add a pop force. 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 Pop force. Where is the pop force? Pop force. We can add this to set like 2. And it's kind of going to kill the entire thing. What we'd like to do is I like to use the VEX expressions and I say amplitude by age. And so now it's just going to do it when it's a bit older, sort of thing. So we can even say amplitude by normalized age, which might not be what you want, honestly. So I tend to go with the age. Here, I'm going to set this to be about 3. I'll set it to be about 0.5 then. And you would normally like layer these on. So we would say, oh, let's add a second one. Let's say this one's 0.5. Let's say this 1, and you would keep on going up and so on, so that you would keep layering on different noises, so that you get different results and so on. we could also do a second one here. So inside of here, we could set a new one. So if we go like this and we adjust the seed, so about 25 maybe, and we adjust this to about 5, I guess. We can even randomize we can sort the point order by random, like so. And if we merge that in, we're going to get two different types of two different streams. Which might be what you want, who knows. Then what we would do is we would use this to drive our Pyro. So I'm going to do a DOP import fields again. In this one I can just use particles, which is going to get with the geometry. Plug this in here. Let's plug this one in here, and I'm going to say pop object. We can even have like a pop force. Wrong. Pop drag. Set to 0.2, use of expression, and we can randomize it, I think. No. Okay. There we go. We can set that out even higher to give it like a bigger spread, and so on. I'm going to keep it to 1 though. And I'm also going to go into this point VOP here, and I'm going to increase this back to 2.4. So I'm going to get very differing values, I hope. And I have a feeling the reason that it's switching so harsh is because we do have this on here, honestly. So I'm going to turn this off, get back. No, that's not it. It is taking like 8 frames to do it though. Oh, not really, is it? But I'm going to put it all back on. I'm going to get the DOP import here from here. And what we can do is I normally increase the amount of points. So I'm going to say about 500 each. Because I like to have a lot of points in my and it's kind of, they're kind of moving in the same way. So let's see if we can adjust. No, this will be fine. Okay, so I now want to create a velocity out of it, volume out of this. And the way we do that is we do volume rasterize attributes. And this takes in a few values. So you're probably going to see the Pyro trail. Is it the Pyro trail? No, it's not Pyro trail. My bad. So the Pyro trail is a different node entirely. I don't know where it's gone because I did lay it down. But we have a Pyro source node. The Pyro source node basically just sets predetermined values. And if we look inside here, we can see those values. So we've got a keep input, we've got a volume scatter, we've got initialize. Let's just say initialize burn. That's just going to give us a burn temperature values, and what that's going to be here, turn this off, is we're going to see it's going to have, come on, where is it? We should be seeing a burn. So we've got temperature there, and we should see a burn there. So burn, and you've got a temperature. I can't find the temperature. But what we can do is we can set a scaling age. So instead of doing it like that, I can use the age from my particles. I can use the force, or I can use the ID. It doesn't really matter. So what I'm going to do is I'm going to say a point VOP, and I'm going to bind import the age. If I plug that directly into my color, we can see that it's going from -1 to white. So I'm going to put down fit range here. I'm going to invert that, basically, or I think I can invert it this way. It's kind of hard to invert something that's not going from full 0 to 1. So we could instead get n age, which is the normalized age. So we have something here called life, and the life attribute. Where's life? Life attribute is going to say us how long it's got left to live. So when it hits that point, then it's dead. When the age is that point. So what we can do to get like a normalized version of that age is we can bind import life, and I can do a divide. So age divided by current life. That will give us a normalized age from 0 to almost white. So that's almost 0. This one's almost white. So this is our normalized age. And I can put down a ramp parameter here. Go in here and I can say, oh, yep, so from these values onwards, or from these values onwards, I want this one to be like burn sort of thing. So I can then set this to be by export. I can set this one to be, and I'm also going to have to change this from a vector to a float. Change from vector to float, doesn't really matter what I'm doing. I can say this one's to the temperature. Oh no, I'm going to say this one's to burn. There's no real difference, honestly, with the way we're doing this. So I've got burn, and I can set another one, except I'm going to make a new ramp, because if I do an old one, then it kind of overrides the other one. Plug this in here, and I can plug this into the color to see what we're getting. And inside here, I can set this to be this one to be mostly burn. This one's going to be burn. Oh, this one's going to be temperature. Sorry, this one's going to be temperature. And then the entire thing is going to be full on density. So I need density in here as well. So I'm going to say bind export density, and I'm just going to make that a constant of 1. And now I want to also talk about speed. So if I want, I want if I wanted the faster areas to be emitting more temperature, what I can do is I can go to bind. I can bring in my velocity, which is coming in from here. And if I plug that into the color, we're going to see this very funky looking shape. But if I get the length of this, then we're going to see the current speed, and the current speed is quite big. So we've got length 1.5 to about 0.5. So let's fit range that back. So it's a fit range. The source minimum is going to be 0.4. Source maximum is going to be 1.5. So now this is getting the proper range. It's not exact. To get an exact one, we would have to do promotion of parameters, and that's kind of a bit tedious to do. And it's not really something we need. We can use this to multiply against these. I'm going to set this to be minimum of 0.5, like so, and I'm also going to put it to here as well. I'm going to multiply this. So now they're all going to be multiplied by the speed. Okay, let's rasterize these. So the attributes is going to be density, and our density is quite big because our particle scale is massive. So let's just let's get rid of a few things after we've used them. So what are we using? We're using the age. We're using the so let's do an attribute delete and a group delete. That's a group create. Okay, group delete, group attributes. I'm going to delete all the groups because I don't really care. So that's all the groups gone. I'm going to say delete non-selected, and I will need the age, the velocity, the life, and I believe that was it. Everything else I don't need. Yep, okay, cool. So now what I need to do is I need to get the particle scale properly. Voxel size, we're going to bring that right down. A bit too much, I'd say, 0.5. But we're going to bring the particle scale right down. So this is a bit too big. So we're going to keep them going down, until we get something a bit like that. You got a filter width, which is like it's like a skinning method. So I'm just going to set this to the default, and I'm going to maybe put this down a bit more. Nope, that worked. And I'm going to say 0.05, so that we're going to get a very nice looking result. Then what I want to do is I want to say, yep, I also want the burn. So that's the burn's going to be added onto that. I also want to do the temperature, and I also want to do the velocity. And so then what I'm going to do, we can also turn on or off the coverage attribute. People have, or turn on the normalize by clamp coverage. It's kind of hard to really see. You've also got a velocity blur, which I've never had great luck with, honestly. But we can try it for now. It can take a little bit time, a bit longer to calculate because of the velocity blur though, and the fact that we've got quite a high resolution. So I'm going to turn it back down. And let's turn the velocity blur back on. It's a little bit slower. That's fine. I'm also going to rename the velocity to val because I prefer it that way. Okay, so let's bring this into another DOP network. What I'm going to do is I'm actually going to cache this out. So say file cache. So that means, which means I don't need to do it again. So it's going to go into the job, sim, my sim source files, source, and then Pyro source, then one more folder, Pyro source $f4, and I'm going to quickly say low save, initialize simulation ops, and hit save to disk. That's just going to quickly simulate it for me. Write it out. I've got 4 people watching. That's interesting. I haven't advertised it anyway. Who else is watching? Okay. So now we've got this one here, and let's bring it into a new DOP network. So it's just a name. I can set. I could have called it whatever I wanted it to. I could have called it my own name. It doesn't matter as long as I put it into the correct source field. So inside here, volume source, and I set operations. The source volume, I can have whatever name I want, but the target field has to be the correct one. So the target field has to be fuel or flame. That's why. So let's bring in the sparse solver, sparse smoke object. Plug these in, and I'm just going to plug it into the first input here, and just say use the first one. And something's wrong because I didn't plug in anything here, so I'm going to say density first. Density, so we can see we're getting density. And I've got to remember to enlarge the field. I've also got to remember to do this, set this down, which will also just make it quite smaller, which means we really have to push this up quite a bit, which can be kind of annoying. So be careful of that. So let's put this to 0.25. Let's add in temperature first. Actually, let's add in our velocity. Let's just add vector to vel. So now we're getting something like that. Okay. Cool. And then also want to do temperature. Temperature. We can see the temperature is quite high. So this is the risk that we have when we were dealing with kind of small scale simulations. So this is only barely a meter. So what we would do here is I could just scale this up, honestly. So I can say transform. What will happen is if I scale this up here, the volume is going to remain the same. So this is about 0.5. Let's go 5, and this is going to be now 0.01 at the 0.05, sorry, at the volume rasterizations. However, we don't really want that, so if we put it over to here, we might have a better result. And actually, I've got to stop that because it's going to do something very drastic. And it's kind of annoying how it does look like that, though. Very blocky. So if we bring this down a little bit, let's just look at the density for now. The density is what we want to be focusing on. So that's this way of doing it. There's another way, which you may or may not like. Okay, so if we go into Windows HScript Textport, we can bring up the old fluid source node. So I'm going to say up and high fluid source, SOP fluid source, and the SOP has to have a capital S. If I now go in here, I can bring up the old fluid source node, and inside here we have a bit of VEX. And I'm just going to quickly refer to this because it's nice and easy. So what I'm going to do is with this lovely particle thing here, I'm also going to do a particle replicate. I'm going to do point replicate. I don't care. I'm going to say about 15 for each. I'm going to say the noise is going to be a sphere, and I'm going to say scale along the velocity. I'm going to say the uniform scale is going to be quite a lot less. The reason I'm doing that is so that I have a lot more points to work with. I'm just going to add some noise to them. I don't really want to be going across like that, though. Okay, I'm just going to say set it to scaled. It's going to give us this weird looking result. That's what we want. I'm going to lay down a bounding box. And so after this bounding box, I'm going to lay down a VDB. This is just a raw VDB node. And this is going to take away from a lot of all this stuff, which is going to be kind of annoying. That's alright, so I'm going to say the name of this is going to be density. It's going to be a float value. And this is going to look like nothing. It's just going to be an empty box. What we need to do is we need to say VDB activate. Plug the bound into the second node here. And now it's going to fill it with some values. I'm going to turn the values off. And I'm going to say reference. It's going to use the bounding box here reference as a reference to how big this should be. Like so. Then I'm going to do a volume wrangle. So it's going to be a lot easier to do in a volume wrangle than it is going to be doing in a VOP. Inside here, we're going to be doing something that's very similar to this, where what we do is we say a PC open, filter, and distance. So, how we do that? We go int. I'm going to make an integer called PC. This stands for point cloud. I'm going to say PC open, which is a point cloud open. I'm going to say for the second input, I need to give it the value of string of p. I need to say attribute p for the current voxel position. And then we have the radius amount and the current points amount. So that's a channel F for float and channel I for points. If I activate that, I'm just going to set it to 10, and I'm going to put this at 0.4. Now we need to get I want to get the position. So say vector pos. And to do that, all I need to do is say PC filter, PC, and then I need to put the attribute in a string of what I want to get, which is going to be P. And now I want to get the distance of that. So if we look inside here, we've got a distance. So I'm going to say distant float D for distance, attribute P, and this position. I can then say F at density equals this. And this is going to be what we call an inverted view. I want to give a bit of feathering and I want to invert it completely. So the way we can do that is I want to use this one. This one's got quite a few things in here. So I need to make 3 custom values called edge location, edge thickness, and feather. So let's just do that quickly. So, and we do this for each one. Well, not each, we just do this once. So it's nice. So I'm going to say float feather. It's going to be channel float of feather. Float edge distance is going to be channel float edge this distance. And I think the next one was edge location. So third edge, it's channel float edge location. Okay. And now, if we take a look, we're taking the edge location and multiplying those two together. So I'm going to keep that. So I'm going to say float edge is going to be the edge of the distance times the edge of the location. If we dive back inside in here, we're using that multiplied to do a fit range. So this fit range is going to go into the distance of the attribute really. So what we can do is we say float edge D, and we say float for density. So I'm going to say den. Then I'm going to say fit this inputting range, which is the distance between the position and that position. And I believe the next one is going to be this edge here. So I need to say edge, and then we say edge plus the feather. Then we say 1 and 0 to invert it. Now, if I push these all up, what we should be seeing is our. I need to actually activate it. So F at density equals this den. There we go. We have an edge distance, edge location, and a feathering range. So I'm going to turn the feathering range down a little bit. I'm going to turn the voxel size down a little bit as well. And this radius is like the point radius thing. And the amount of points we have. The amount of points doesn't really count, so I'm just going to keep it at the value of 10 default. And now all we need to do is I can keep this den range the same, but I want to get the different attributes over. Those are the no attributes. This one has an attributes, copy source attributes. There we go. So I want to copy over the burn, density, temperature, and the velocity. So what I'm going to do is I'm going to create a few new fields. So this one was density. This one is going to be temperature. This one is going to be burn. Actually, I'm going to I'll call it flame, just so you don't get confused. This one's going to call val, and instead of this type, I'm going to set the type to a vector float. I'm just going to keep it to displacement. Okay. I'm also going to hide. So which one was it? Visibility. I want to turn off everything except for the density. Actually, I'm going to keep that on for now. And what I want to do is I now want to get the the actual values of those. So I'm going to say float density val is going to be the PC filter. You can still use the same PC. I'm going to say density. I'm going to copy paste this a few times. So this one's going to be the temperature val. This one's going to be the flame. This one's going to be the velocity. So this one needs to be changing the type as well to the vector. This one's going to be V, I believe. Yep, V. This one is going to be burn, because that's what I called it originally. And this one will be temperature. And then we just multiply this by the density value, like so. Okay. And then I can just say at temperature equals, well, not this, but I'm going to hide this right now. And I'm going to say temperature value here. So now we can see that's the temperature value. I'm going to hide that so we can just see what we're doing. This one's going to be a burn. I'm going to flame, sorry. Flame by a flame value. See, it's a bit shorter. And we don't really need to see the velocity. And we don't even need to multiply it by the density, honestly. So we just say the val. So that's just going to fill this entire thing up, like so. If we made this a bit bigger, we would get a bigger result. So you might want to do another PC filter of that. So PC2, and we're going to change the radius bigger, and inside here we're going to call this PC2. So now we're getting a larger radius for our velocity. Turn off the visibility of all those, and I'm just going to turn it back on, so that's doing all that. So now we're getting all this. And this is a method that I use quite a lot. The only downside, I believe, was the it sometimes would make a value at world 0. But we've already got a value at world 0, so that's fine. But to get around that, I'll show you how to do that. So to get around this, we would encapsulate this entire thing. So insert inside of here. So encapsulating this entire thing, we would set it to be this. So I'm going to say, if the PC num found of PC is greater than 0, then do everything inside here. I'm also going to do an AND. PC num found, PC 2 is greater than 0. Hopefully that won't change anything. But what happens there is that it kind of makes a value in the very middle that we don't want. So this is a fix that I found a while ago for that. Very easy fix, honestly, but something I should have known. So now I'm just going to quickly cache this out again. It's taking a bit longer now because of the scaled up and the fact that we're using custom VEX. Okay. Let's take a look at that. Yep. Ooh. I need to turn this down. I also need to set my fields up. So let's take a look at temperature. Ah, yes. Exactly what I wanted. Density, and then temperature. We could use temperature or flame. Don't think it matters. It does matter. Let's say flame. Flame. I'm not really seeing anything there. Just a little work. Oh wait, I did turn on, did I? There we go. Not very bright. So let's go back to here. So we're not seeing any flame. Let's go back to temperature. Temperature. Now we're seeing the temperature because the temperature is coming in from here. So let's bring in our burn. So we've got burn, we've got flame, and yeah, it's just called flame. Okay. So let's say flame to flame. And we're seeing some kind of stepping effects here. Not always wanted. So what we want to do is I want to turn down the buoyancy scale quite a bit. So let's say 0.4. And I set the cooling rate to 0.7. Temperature fusion to let's say 0.1. And I'm also going to then enable these. So I'm going to enable these all. I'm just going to keep them at default for now. Yep. Okay, we're not really seeing smoke, are we? So let's try the add method. It's kind of hot. I don't like this look, so I'm going to go to the DOP import fields, bring in the fields, smoke, sparse one, and I say choose the Pyro, and then I'm going to do Pyro bake volume because that is quite a nice look. We're still not getting enough smoke in my opinion. So I want to get more smoke. So let's go to the temperature. Let's add density to that. Let's turn this down a little bit. Cooling rate might be a bit too much, honestly. Yeah, the cooling rate might be just a bit too much. Let's turn, oh wait, a little down. So I'm going to go back to here. I'm going to split that to 1. Let's set this up to be quite high. Let's add a bit more expansion. Alright, maybe too much expansion. We're also not getting enough of this working. So what we can do is I can either push the velocity quite a lot higher, but that's not really what I want to do. So honestly, the best method is to make a duplicate of this. No, not really. Kind of. So I'm just going to plug in it again. In this volume source here, I'm just going to delete everything, and I'm going to say pump. This is going to give us like a pump field. And the way I'm going to do that is I'm going to set the density into the pump and a velocity into the pump. What this is going to do is it's going to give us like this sort of scaled effect, as it were. It should, technically, pull the velocity in to us. So we're getting something a bit like that. So the smoke is being, the fire is being pushed out a lot more. We're getting some stepping. So I'm going to turn this down. I'm going to turn this up to 4. Set the smoke up to about 3. Lifespan to be about 3. Dissipation down to 0.2. Temperature revision up to 2. Cooling rate down to 0.4. Ambient, let's keep that the same. Let's add some disturbance shading in this. I'm just going to keep these defaults. Then, so some stepping can occur when you're doing like so we're getting very harsh looking, these sorts of things. So that's coming from the this one here. So we can either add to the padding. So I'm going to add to the padding to about 1.2, resizing. Some people recommend turning off the sparse solver, and I do too, technically, because I'm going to turn the buoyancy scale down as well, because it can really mess with it. I'm just going to go back up, and I'm going to grab these 3. I'm just going to chuck them in here under the forces. And as you can see, we're not actually getting a lot of variation here. Not really what we want. So let's work on fixing that. So I'm going to go into here, and I want to do a scatter onto the density, please. I don't care about the relaxation, it just speeds it up. I'm going to do volume trail, and I want to see what my velocity is looking like. That's what it's looking like. I want to noise this up. So I'm going to do a bind. I'm going to do a volume block here. I'm going to do a bind export and bind import. So I'm going to say bind import, I'm going to say val. It's going to be a vector. This is going to go into here, and this is also going to be a val. Making sure this is a vector as well, because otherwise it might muck up. I'm going to say add, and I want to add in, not the position, I want to add in a curl noise, like I did last time. Perlin noise tends to work the best, so I'm going to increase the frequency. I'm going to keep it like that. I can also scale it by the how strong the velocity is. So I can say val, yeah, I'll just keep it like this. So that's that one. So I'll plug it in here. So this should hopefully give us a bit more of a noise. This is coming out. It's not. That is a little annoying. The reason for that is because this is still growing. So we could put down a time shift. So time shift here. And I'm going to say plus 10. Let's go plus 25. So that the velocity is already there. We normally want the velocity to be already there by the time we're starting this pump. This is what the pump is doing properly. Okay. And I need to reset something to make it reset the solver. Not too sure why this isn't having any effect. Throw into the advection and see if that makes any changes. Okay, that's not changing at all. Let's just throw this one into it then. And let's just change this. 15, well, yes, let's go 0 to 1. Just keep it the same. Okay, so I've got the things wrong. So let's go back to 2. Actually, what was this one? This one was at 5. This one was that. Okay. Okay, let's plug you in. Let's change this from 0 to, say 0 to 2. However, ideally, what we would have here is we would have a bit more noise, which is annoying why it's not working. So let's plug this one in as well. There. Alright, so we've got that time offset. It's not what we want, so let's put the time offset here. So the time offset is happening later on. Move this out of the way. Right out of the way. And I have a feeling if we scale this one in the negative, it'll behave a little bit differently. Not quite. Not quite the result I wanted, honestly. So 0.5. Just so that it's not scaling that much. And this one I'm going to set it to be about 15. Bit too hard. So free. Had it at 5 originally. And now we're not. Now they're fighting against each other here. So let's put this to about 0.1. Let's put it back to 1 again. It's really hard to get get rid of this without reverting to another practice. But let's try that practice anyway. So the result's ending up to be about. Come on, I don't want to view this. View that. So what I'm going to do is I'm going to go all the way back up here. Grab this. And I'm going to set a line. And under here, I'm going to say add. I say copy 2 points. Here. There we can see we've got something like this. It's not pointing in the right direction though, as you can probably tell. So we just need to change this. Come on. This around. So I think it's like that. Nope. It'll be along the z-axis there. There we go. Then what we need to do is we need to just adjust the length. The length will be, let's say about, let's say the length is going to be 15. Let's add about 500 points in between there. Let's add in a bit of a tube. So let's add in, no, yes. And we're going to do something like this here. So I'm going to copy this. Line here. Plug it in. Plug it in there. And because I'm not going to get density value, I'm not doing anything with the val. Can. So I'm going to keep that one there. Okay, so I'm going to keep this, get rid of this, get rid of this, get rid of that. Now what we should get is we should get something like this. We should get like this polyline between the two. I'm going to expand this quite a lot. The downside to this is that, come on, downside to this is that it's not quite going to show us a good result. So let's, okay, I can turn this down. But, oops, test by 2. I'm also going to get rid of the flame, and I'm going to get rid of the temperature. The bound, however, needs to have a 2 by 2 by 2 sort of thing around it, so that it actually does encapsulate the entire thing. Let's say 2. Turn these off, then we have like this full-on feather thing. Kind of what we want. What I want to do though is I also want to add in a velocity along the x, so that's an attribute angle. V at val is along the, just along the z, really, just so that we have a velocity to look at. So let's try looking at that velocity. As you can see, it is getting the velocity correctly. You can also see that it's kind of not working great, because it's just the size of this, and it's quite slow. So we're going to have to cache this one out as well. So this is going to be the pump source. And inside of here, I can then just add in this noise. I'm also going to turn this down. Okay, and I'm going to save that out. So this one's going to take a bit longer because of the the VEX involved and everything. So let's sit back and wait. So I've got a Threadripper, what is it? A Threadripper 3970X, and 128 gigabytes of memory. I'm looking to upgrade that in the future to 256, but that's another day. And I've got an old 1080 Ti, which was new, but it's now pretty. It's getting on in its years. So, what else? Oh, and about several hundred disk drives. All of them just absolutely filled with junk. Come on. As you can see. I believe this one's just filled with libraries for programming. With this one's some of these are all backups. This one's got all my files for projects and stuff in, and these two are new, so they haven't been filled yet. Really close. I might have to call it a night after this because I do have to be up rather early tomorrow to get to appointments and stuff. Okay. So I've got that. Let's add that into here and see if that's done anything to help our current situation. Oh, I've got messages. So um one-on-one class, I'm probably not ready for that just yet, honestly. I can try, maybe. It's, yeah. We'll have to talk about that later. But okay, what's taking? Oh, right, it's simming. It's trying to sim. I see. I am not smart. I'm going to turn this down to 1 to 1. Didn't help it at all. That's so annoying. It's still got this one big giant fireball. So I'm going to hack it a little bit. I'm going to say, hey, volume. I'll answer your question in a second. Sorry. Volume VOP. Dive inside here. Bind. Export the temperature. Temperature. Let's do another bind. This one's going to also be the temperature. So I'm just going to bring it in. I'm going to say yes, yes. I want to visualize this too, so I'm going to put down a volume is, and I'm just going to say I want to visualize the temperature, please. Why am I not visualizing the temperature? Do I have to set its density? That's stupid. Right, turn you down. There's my temperature. I'm just going to look at the temperature for now. I'll talk about the flame in a second. And I'm just going to do that. Vector 2, vector 4 thing I did last time, honestly, because it's easier. Vector 2 frame, let's just say time, set frame. Voronoi noise, just going to automatically go to there. Just going to subtract between these two distances to get a Voronoi distance between the two, and then I'm going to multiply the temperature by that. So we're going to get something a bit like this. I cannot remember how to get like a difference between the two. So something like that. Actually, honestly, it's probably better to just use like a noise, proper noise. So let's go AA noise. Yep, something like that. Increase the frequency a little bit. So flame and temperature. What's happening here? Stupid thing. Is what have I got here? I've got vel and density. Let's take a look. Simulation. Advanced. Advection. Oh, that's no. Shape. No. No. Simulation. I don't know if it's taking into account the pump. That's the problem. So I can't even see pump here. Inside of So we've got two versions of the solvers. We've got the sparse solver and we've got the old solver. I'm actually going to turn off the sparsity, and I'll tell you what they both do. I need to also enable sparse solving, turn that off. What they both do. So now this is similar to the old solver in a way, kind of. Heck, we can even add like a LFF sort of thing. We can say fit between, I don't know, 0, 0, 35 to 0, 3. So then it's just going to increase over time. Again, I still don't know if this is working. Hey, that's the first context jump. Let's go to the second one. Far out. Yes, it is working. Okay. I'm going to turn that off. Put it back to free. So, the difference between these two, the problem with that is it's going to get this. It's a player's game here. So temperature, it is emitting temperature right now. Temperature is there, but the temperature isn't currently advecting itself. It's not doing anything. But what's happening is smoke is being made from this temperature, because the way that this works, these lovely sparse solver works, is that it takes in, the old one, it will take in fuel and temperature. It would create several new fields such as burn, heat, divergence. That kind of the first two are self-explanatory. So burn is what it's burning currently. The heat is the heat that's being outputted, and divergence is like imagine like a density field, but it when temperature goes into it, or when other fields into it, it'll expand it, which is why we've got something in here called expansion. That's basically what divergence is. I can even showcase that by saying divergence. So I'm going to take from the flame field, I'm going to take the flame field, I'm going to make it something called divergence out of it. That's not even going to show it, is it? Oh, right, because I've got to set it to 1. I've got to actually make sure it's being added. Still not really doing anything, is it? It's kind of annoying when some things don't work the way you want it to. Is there a flame field? Yeah, it's flame. Okay. Not too sure why it's not really working. Density, temperature. Take a look at the divergence then. So have a divergence field here we can visualize. Let's go to the divergence. Let's go to the ZX plane. And we can see we're getting some divergence sort of thing here. That must be copy, that must be add. But the divergence, I think it's getting turned off because of this expansion thing. I'm not too sure. So let's turn off that and go back to multi-field. So the new one, it takes in flame and temperature, and it just outputs temperature, which in my mind is a little less intuitive and also prone to some muck-ups later on, but it also helps just streamline some people's views, how it should work and so on. Now we're getting that. If we wanted to add a bit more temperature, I'm going to add 15 to the temperature here. Going to add a bit more to the flame. So add to the flame. Let's add a bit more. Let's add the expansion to 1.2. You can see how it's kind of expanding on itself a little bit. So it might be a bit too much. So I'm going to turn that down. I'm going to turn on the smoke, turn up the temperature. Lifespan is going to be 6. I'm going to cool down the cooling rate, sorry. So we're going to get something like that, which may or may be what you want. Let's try adding in 2 to here, and let's add in 2 to here. Let's jump back out. Let's take a look at it, and let's just sim it up to that point. So after I've done that, I'll just quickly do it with the old solver, and I will send you these files too, because it might help you. Who knows? So there's that one. So I've got the old solver as well. Let's try the old solver. Duplicate this. Jump back out. Jump back in. I'm going to delete these 2. So let's see, smoke, object, smoke, pyro solver. Plug that in. Plug that in. Do the resize fluid dynamic. And plug this into the sourcing, and plug this one into the velocity update. This max bounds, I'm going to put it about 0.2. The max bounds, I'm also going to turn off the clamp to maximum, and tracking object, I need to make a tracking object. So there's 2 ways to make a tracking object. One was making the null, like you saw. Second one is if I plug it into here, and I want to get like how this one is doing source first input. The way we do that is we put in 2 ampersands. I think they're ampersands. We go op input path. We put in we put in brackets. We say dot. We go 2 quotation marks. Put down 2 full stops, comma, and then the one the input that we want. So for mine, because it was number 0, 1, 2, it's going to be number 2, like so. And if I middle click, I can see it's being evaluated to that. Keep it to 0.2. If I start running this, it's just going to look like that. So I need to say, let's make a multi-field, say density and temperature. That's not how you spell temperature. And in here we've got a combustion. So all I need to do to change this is I'm going to say change this from flame to fuel. And I might actually change that around so that temperature is going into fuel and flame. So the temperature was the one that I noised up, and the flame is going to be going into there. So I'm going to turn down the fuel a little bit too. Then going to turn this down. Combustion, I'm going to say 25. Smoke, actually create dense smoke. Burn rate, yes, it's fine. The buoyancy lift to 2. And I'm just going to turn on all these. Okay. Let's quickly simulate that. Okay. So that's not the result I was hoping for. So I'm going to turn off all this. Shut you off. Turn off all these. Let's go temperature, fuel, flame, temperature, valve, and density. So I'm just going to get rid of all these, and I'm just going to talk about these two. So I'm going to get rid of the valve, turn that off. I want my combustion to be working. My combustion should be working, so I'm going to say flame into the fuel as well. Oops. 55 is a bit too much, honestly, but it actually might work. So there's a few things you can do to give it a lot. So I'm going to plug this one back in. You can see it's trying to move now a bit. I'm going to set this back. So the fuel is really kind of taking over here. So about 6. And now the buoyancy is really pushing it up high, so I'm going to put it back down to 2. And now we're getting something similar to what I actually wanted from this. It's a little light. So where we can change that is I can copy these and I can just move this down a little bit. See where the temperature is. Let's plug in these. Let's maybe turn down this swirl size to about 0.5. This one to be about 0.2. And this block down a little bit less than that. Then what I might want to do is I want to say, let's say that 20. The gas, it's there. The flames, nope. I'm going to say no, don't create dead smoke. And the fuel inefficiency, I'm going to put it about 0.5. Temperature output, I'm going to put it about 1. That's probably a mistake. So let's go back. I'll put it back down to 0.2. Fuel inefficiency, I'm actually going to put that back down to about 0.1. Initial temperature, I'm going to put that back up. What it was, rest the defaults, please. And then I'm going to turn on all these. I've kind of lost some of the individuality of it, honestly, with the this. So let's take that out and see if that's actually changing it, or if it was this combustion stuff that I was doing here. I don't know. Probably was this. So let's put it back down to about 15. Flames, make it 8. Simulation, 1. Diffusion, 0.2. Just 0.25. And again, we can probably scale this down. So let's do that. I'm going to put in a transform. And I'll scale this down to 0.5. I'm also going to scale this one down. Oops, I hit the go all. And I'm going to raise the resolution. Okay. This is very flame powered there. Still getting that. This, there's a there's a technique to fix that, but it's not something I want to show here. Let's look at, getting the wrong one. Getting the one from the sparse. So let's get the one from the second one. So number 2, and this one is getting the one from the smoke object. Wow. And that's probably a little bit too bright, honestly. So we would change this. So what's wrong with this? Not the visible. No, it's not effect rendering. That's fine. Let's turn the density scale back to 15. Let's turn that scatterfire. This scatterfire at least down a little bit. So now we can get a little bit more of that details in there. I think the sparse one looked better, honestly. Even if it was a little bit bigger. It's basically just tweaking little values and such, and trying to get rid of these mushroom shapes. And honestly, it's very hard to get rid of the mushroom shapes. So let's try. I'm just going to make 2 mute gas turbulence nodes. Exactly. I'm going to turn this off. Turn this off so it's a bit faster to see. I'm going to get the same results. 0.2. The only difference being is that I'm going to use in my control field. I'm going to use what they say to use. I'm actually going to use temperature. This. So that was that one. With this one. This one was 0.5 and 2. Okay. Well, actually, it would help if I actually plugged it in, wouldn't it? We're getting not really a great amount of breakup there, though. For some reason, they weren't plugged in before, so I'm going to replug the other ones back in. Get rid of these. Hit go again one more time. Getting a little bit of breakup. Not a great deal though. Not enough. Not what I want. Not good enough. So 2. And you really want to be careful with the turbulence because it can actually just destroy the whole thing, like it's doing now. So let's turn you off. It's hard to remember if the swirl size is bigger, then if the swirl size is bigger, then is the actual thing bigger? Or if it's bigger doesn't mean there's more of it, so it means that it's a smaller frequency. It's kind of hard to really judge. That looks a lot nicer. Well, nicer, I say. It looks a lot more palatable with the actual flames being destroyed. Yeah, there we go. I reckon that looks a bit nicer. So next time, remember to plug in the nodes. Okay. Hoping that helped. So fuel and temperature is used by the old Pyro solver. The new Pyro solver uses flame and temperature. I actually don't think it even uses temperature at all. Honestly, if I wasn't using the fuel inside here, I'm going to get rid of the flame. I'm going to showcase something quickly. I could actually just say smoke solver sparse here. Enable sparse solving, please. And we're still going to see the temperature. The only difference is it's not going to be doing all the extra things, because if we look inside the, put it back to 0, we look inside the Pyro solver and we look inside the Pyro solver sparse. So I'm going to unlock both of them. Allow editing. If we look inside the Pyro solver, this is the old one. We can see at the very base it's building onto the smoke solver, and it's just building in extra things such as shape operators, which is the those extra shapes here, and the fuel model here. Oh no, this is the fuel model here. This is the combustion model here. This is just helping with the combustion model. This is just basically advection of it all. And if we look at our sparse solver, we've got the same thing. We're using the smoke solver down here with just a few extra bells and whistles, such as dissipation, blurring. And so where is that's the sharpen, that's the advection, that's the dissipation. So dissipation, this is the flames. So this is the flames. So it's got the smoke solver. It's all done in one massively big pile of VEX. These if statements, great. The reason they don't code it out like they have. So if we take a look at this thing, this is what we call a kernel. I'll explain it in a second. But this is the reason they use a VOP node instead of VEX. Is if I lay down, if I go up to here, I lay down a wrangle, and I dive inside it, we can see it's just a VOP. Inside the VOP is got something called a snippet node, and that's as deep as we can go. So I can literally just say point VOP snippet, and I can now write VEX inside of VOPs here. The only difference is that the VEX node auto binds all the stuff that we make, all the attributes we make inside the VEX node. It just binds to it automatically, so it's a lot easier to run. And added to that is that these nodes are already compiled. So these are already compiled into from C++ into machine code, which is assembly. Yeah, it would be, yeah, it's assembly, which the machine can run extremely fast. With something like VEX, it can take a little bit longer. It comes down to what you're using. The VEX code is very, very fast. I'm not going to say it's not, but it's so for example, if we lay down, say, like a principled shader sort of thing, if we dive inside it, you can see it doesn't display because it's using a cached VEX code, so it doesn't even need to generate the VOPs. However, if I right click on this and say allow editing, it's going to take a few seconds, and you can see that little purple thing there disappeared and now we have all the nodes. But if I say match current definition, we're going to see that this little thing up here is now full again, which means using a cached version, which means that it's using a compiled version of the code, so it's going to run a lot faster. But inside here, another thing, you got something in here called flamecl, and you've already got flameVEX and flamecl. Now, CL stands for OpenCL, which is what our graphics card runs. So when you go into here, you go to advanced and you say use OpenCL, then it will use your graphics card to run, and sometimes that can be faster, sometimes it cannot. It really does depend. I deleted that one, didn't I? Oh no, I deleted that one. Oh bugger, that's annoying. I deleted that. What how far back I can go? Because I want that back. There we go. Okay, we got it back. Here, that's what the OpenCL is, and this. So I just die if I make a sparse. And this is true of both of them. If I look inside here, there's something called flamecl, and this is using a kernel, and it's using something called a sim kernel. And what we can do is we can figure out where this is actually running from. The way I do that is I'm going to say ultra search, because this is my custom. So the search engine inside of Windows is kind of unreliable. We just turn off all my drives, so I know where it's actually located. The search engine inside of Windows is kind of unreliable because it needs to be cached, which is kind of stupid. So I just use this thing here. I'm going to say Pyro CL, and I'm going to open where that is. That's it. Thank you. We can see it's under Houdini, OCL, simulation. So we've got like compute, so we've got like a vector and stuff like that, and grid-based things. And we've got the simulation. We've got like which one is it? This one is Pyro. If we go into Pyro, I'm going to open that up in my code editor. We can see all the code for all the different yes, save. We can see all the code for all the different nodes inside here. This one's looking for something called manage heat. So if I just go to here, I can say manage heat. We can see all the inputs that it's taking. So it's taking all these little different inputs, which if we go into the bindings, we can see that's what we're putting in. So we've got temperature, we've got divergence, aging, suit rate, so on, and then it actually starts going over it all. And it will probably use all the stuff up here as well, but it also it's using a lot of the values that so this IDX thing, trying to remember if that's some it's been a long time since I've had to write kernel code, so I did that back for when I did Unity coding for speeding up some stuff. But yeah, that's I kind of run out of things to say, and it's what's the time? It's almost 3 o'clock, so I need to go. As I said, I had to be up early today. So hope that helped in some regard. I'll send you the file as well. I'll send you the file. If anyone else wants it, then just let me know and I'll put it up available for people to grab. But for now, that's the file. That's how we do. That's how I do simulation work inside of Houdini. It's what's wrong with you? Foam source doesn't like something in there. Advanced sparsity enables fast solving. What don't you like? Doesn't like the transform. No. Let's just figure this one out. Resizing intensity. Nope. 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 Turn you off. Turn you off. Take a look. Okay. I'm gonna disable you. Okay. Failed to cook. Interesting. I think it's because I did all that backspacing. But yes, there you go. The old one should work. This one should work. Back. Yep, this one works. Cool. Okay. I shall call it a night here. And I shall see you later. I don't know.